Okay, this is Unit 4, Lesson 10, second semester, 7th grade math. Vocabulary review. What is the measure of any right angle? Who's got that? Justin? 90 degrees. Very good. All right, so I'm going to go ahead and have you guys tell me first, before I draw the angles, if they're acute, right, obtuse, or straight. So for number 2, is that acute or obtuse? Acute. Acute. Number 3, acute, obtuse, straight, right, obtuse? Yep. Number 4? Right angle. And number 5, straight angle. Okay, let's go ahead. I will draw the angles using this protractor. Okay, 60-degree angle, and then 120-degree angle. That's my obtuse angle, and then my 90-degree angle. Okay, and then obviously we have our straight angle. Okay, any questions? Notice on the protractor, these angle pairs that are opposite each other are what? So these set of angles that are right next to each other on the protractor, what do we call those? Supplementary angle pairs, and they add up to be what? 180. Okay, I'll go ahead and read this. What you'll learn: to identify rotational symmetry and to rotate a figure about a point. New vocabulary: rotation, center of rotation, rotational symmetry, angle of rotation. Why learn this? Some objects rotate, which means to move in a circular manner. When you ride a unicycle, the wheel rotates and you move. A figure has rotation, excuse me. A figure has rotation a figure having rotation is a transformation that turns a figure about a fixed point called a center of rotation. There's a typo in there. You describe a rotation by its angle measure and its direction. The direction of every rotation in this book is counterclockwise unless noted clockwise. In a figure, if a figure can be 180 degrees or less and match the original figure, it has rotational symmetry. So you can rotate a figure clockwise or counterclockwise. Just how this book is, they're saying if I don't tell you which way to rotate it, then assume it's counterclockwise. Connexus, the assessments, are a little different than that. Know which direction, counterclockwise, clockwise. And I'm going to review that with you in this lesson. Okay, so that's a bit to talk about, but this is the third transformation we're learning about: rotation. All right, rotational symmetry. So we're going to identify some rotational symmetry. So I want to kind of walk you through what is a clockwise rotation and a counterclockwise rotation, so we're prepared for both types of questions that we might see. Okay, so here we have this windmill and the sails of the windmill. They have rotational symmetry. So let's take a look. In this first picture on the left, I want to match this first picture over here. How many degrees are we rotating this counterclockwise, and how many are we rotating it clockwise? So counterclockwise. And then we'll have our answer in clockwise rotation. And we'll do that for each of these. Make some space here for our answers. So for the first picture here on the left, if I rotate it clockwise, how many rotations, how many degrees would I rotate it clockwise to get to that position? How many degrees did I just rotate it clockwise? So each quarter turn is how many degrees? 90. Am I matching my picture on the left? No. So how many degrees did I rotate it now? 90 plus 90, so 2 times 90 is 180. So it's 180. Am I matching that picture on the left? No. So I need to rotate another quarter turn. So 270 clockwise. Degrees clockwise. Now, counterclockwise. So if I'm my original, and I rotate it counterclockwise, I'm going left, turning left.
Good afternoon, College Park Academy. Please pardon this interruption.
How many degrees did I rotate it? Is it matching?
Will begin shortly. All students should be in their 4th period class. Again, all students should be in their 4th period class, and Parks testing will resume.
So 90 degrees, 270 degrees clockwise. Now I need to make my image match what I have here in the second picture. So how many degrees am I going to rotate it clockwise in the second picture? Very good. So clockwise, 90, 180, it's upside down. That's 180 degrees. And what you'll notice, okay, hold on a second. No, it's having a hard time today. 180 degree rotation clockwise. What would the degree rotation be counterclockwise? 180 degrees counterclockwise gets me to the same position. Okay, and the third picture. So clockwise, how many degrees would I rotate this clockwise to get to the third picture? 90 degrees clockwise, right? What about counterclockwise? So if I was to rotate this.
Please pardon the interruption. Mr. Bay,
1,
please report to the
2,
ISD for Mr.
3 quarter turns, so 3 times 90. How many? 270 degrees. Now, there's another rotational symmetry, or degrees of rotation. It's what takes us back to the original image. So to do a full turn clockwise is how many degrees? Okay? And if I go a full rotation counterclockwise, does that take me back to the original image? So again, .360. I'm going to put CW for clockwise, and then 360 degrees for counterclockwise. Okay, any questions? All right. Now, take a look at this. Does the figure have rotational symmetry? Remember the definition up above said if you can rotate it 180 degrees or less and it looks like the original, then you have rotational symmetry. Can I rotate that less than 180 degrees and have it look like the original? How many different positions can I rotate this so that it looks like the original? 5. Let's go through and count them. 1, 2, 3, 4, 5, right? Now, what's the degree of rotation? 360? Well, 360 is one full rotation, but each turn that I made that made it look like the original, how many degrees did I turn it? Not 90. how can we calculate the degree of rotation? Rehan?
So since you rotate 5 multiply 360 by 5.
There are 5 positions, and we know for a full rotation it's 360 degrees, right? So if I divide that by the number of positions that look like the original, 5, I'll get the degree of each turn that makes it look like the original, which is what?
70.
What's that? 72 degrees. Okay. Is this next one, does this have rotational symmetry? No, it doesn't. So it's not even there's no symmetry at all there, right? What about this one? Can I rotate it 180 degrees or less and have it look like the original?
Yes.
How many degrees did I just rotate it? Does that look like the original? No. What about now? Does that look like the original? How many degrees did I rotate it? So that's one position, and then a full rotation looks like the original, so how many positions look like the original? 2. So what would be the angle of rotation? 360 degrees divided by the number of positions that look like the original, which is 2, and that gives us back what? 180 degrees. Okay, any questions? Pretty easy. So the first one, yes, we have rotational symmetry, and the second one, yes, we had rotational symmetry. The second one, nope. So the first and the third, second one, no. All right. So the number of degrees a figure rotates is the angle of rotation. When a figure has rotational symmetry, the angle of rotation is the angle measure the figure must rotate to match the original figure. So this actually is similar to what we just did, right? So this is just like the last problem. What's the angle of rotation? There's how many positions that look like the original? There's 5, so you take a full rotation, divide by what? The number of positions that match the original, in this case is 5, and we already calculated that for our previous example, and we found that to be 72 degrees. Let's take a look at this. In nature, we often see symmetry. How many different positions do we have for this flower? How many positions will match pretty close to the original? 6, right? So if we have 6 positions that match the original, we take a full rotation and divide by 6, and what do we get back? 60 degrees. Okay, any questions? All right, next coordinate plane. Take some time, look at this problem, see if you can figure out where my new coordinates will be. I'm rotating rectangle ABCD about the center of rotation is going to be the origin. It doesn't have to be the origin. In this case, it's the origin. What are my new coordinates going to be? Try it, work it out, because the next one's not going to be as obvious. Okay, what are my new coordinates? Does A change? No, that's where we're rotating. We're rotating about the point A. So the image of A is just going to stay the same. What about the image of B? Where is that end up? Yep. Negative 2, 0. Is she right? Negative 2, 0 would be right here. So if I rotated, that would be 90 degrees, but we want 180 degrees.
No, B does not change.
Okay.
C and B will change.
Nope, I don't agree with you. Leah?
If you rotate this way
180 degree counterclockwise. 0, negative 2, yes. Okay. How about C? What's C going to be? Who's got C? Nicole, can you give me a guess for C, the image of C? C primed. If I rotate this 180 degrees left, counterclockwise, where's my image of C going to be? Below it, but can you give me the coordinate, like the precise points? You're close. Can somebody help her out? Teray? Negative 4, 0, but no, that wouldn't be C. That would be D would be negative 4, 0. What's C going to be? Athelia, you got a guess? Where's my image of C going to be at? If I rotate this whole thing about the origin, where's my image of C? 2 and negative 4? Nope. That's right here. Zainab, can you help her out? 0 and 4? Nope. That's not right either. Bokar? Negative 4 and negative 2. Good, that would be C. So let me show you, I'm going to show you the answer once I draw it in. Do you guys see if how I'm rotating it? Okay. So if I rotated this, this is where my image would end up for those points. Okay. Now, that's to me, that's an easier one. Can somebody tell me what's the rule that we can write for a 180 degree rotation? What would the rule be for that? If I have an X and a Y, what would my arrow rule notation be? What would my arrow rule be notation for that? What's happening to my values of X? Let's go ahead and put these in here. So B, they told us, was 0, 2. C is 4, 2. D is 4, 0. A is 0, 0. Okay. A primed is 0, 0. B is going to be 0, negative 2. Surprise, nobody said anything yet. C is going to be negative 4, negative 2. And then D is going to be negative 4, 0. So what's my rule? Nicole, you got it?
No, it's that like for C, like you after the guess and that's what I guessed. I said
Okay, no, it's okay if you guessed. Your answer wasn't correct, though. But can you help me out with my rule? What's happening to my X and Y coordinates when I start out with the original and end up with the image? They're all becoming negatives, right? So how would I write that in my arrow notation? Remember from last week? The signs are changing, so how do we change the signs of something? How do we represent that algebraically? Can somebody help her out? What's the expression I can use to represent that change in sign, not magnitude? Miriam? Negative 1x and negative 1y. That is my rule. Now, that only works for this transformation. Every transformation is going to have a different rule. So, how about we take a look at this one? Now, guess what? Are we rotating about the center, the origin? No. They want us to rotate it about the point 2,1. That's the point 2,1. So we're rotating it around that point. So I need you guys to calculate the new points. And for this one, I wouldn't expect you guys to figure out the rule for this. The one above, maybe. This one, no. So take a moment. Come up with the image points for A, B, C, and D. I'm going to wait till everybody's had an opportunity to write these out. When you're done, put your pencils down. When you're done. You have a question? Remember, if for the book it says if it doesn't tell you, counterclockwise. Okay. Other tests like the park will probably tell you counterclockwise or clockwise. The book is saying, hey, if I don't tell you, it's counterclockwise. Okay? But you're right. It does matter. What are my new points going to be? Can somebody tell me what my new A is going to be? My image of A. Goldus is the only one. What's that? 2 what? 2 and 1 for A. If I rotated this whole thing about that center of rotation? No. What about you, Theo? 0, 0. No, that's only if we were rotating about the origin. That's not true. Ben?
2, 4.
2 and 4. You're saying that's my new point for A? Nope. I think maybe you're not exactly comprehending what it's telling you. It's saying, hey, if I have this, and I rotate that, that's where I'm rotating it. Got it? Do you understand? It's not rotating about the origin. It's rotating about that point 2,1. Does that make sense? The other one was rotating at the origin. This one's not rotating about the origin. So, my new points, and this one I wouldn't expect you guys to get the rule for. Later, like as you get into like actual algebra, you might be required to do that. But my new point, C to C primed, well, C is 4, 2. This is going to be 1, 3. And then D is going to be 3, 3. A, 3, negative 1. B, negative 1, negative 1. Okay, again, I wouldn't necessarily expect you guys to come up with the rule for this. There is a way to do it. I'm not going to get into that now because you're not going to be required to do this tomorrow for this type of rotation. Got it? Just be able to identify where the new points are going to be. Okay? All right. Now what I need you guys to do for this one is a rotation about the origin. So we have this graph of this triangle, TRG, and it's being rotated about the origin 180 degrees. And since the book doesn't tell us what direction do we assume it to be? Counterclockwise. So it's going to be a counterclockwise rotation. 180 degrees, about point T. I need you guys to figure out what your new points are going to be. Take a guess. See if you can figure it out. I'm going to reveal the solution to you in a second.
What does the above mean again?
It means that's the place you're going to spin it around. Jonathan, can you tell me where my new T is going to be? It's going to stay the same. So my new T primed, going to stay right there, 0, 0. What about my R? What's my new R going to be? Do you know where that is? Can you tell me which quadrant it is? Quadrant 3, you're correct. Can you tell me the coordinate for R primed, or the image of R? -3, -3. Very good. Okay, that's R primed. Okay, and what about G, the last point? -5, -1. Very good. That is G primed. Okay, if I was to connect all this up, we good? So here's the answer. And actually, you would just use the same rule that we came up with before, right? You're just multiplying negative to x, negative to y, right? Okay. Now, end of the lesson. Name 2 types of symmetry. What are the 2 types of symmetry? Who can name one of them? Justin. Rotational symmetry. What's the other one? Line symmetry. I feel like the book, this is kind of using this as a synonym for reflectional symmetry. Oops. Okay. Yep. Okay, so these two, be ready to use either. They're synonyms. Name 3 types of transformations. What are the 3 types of transformations? Give me one. Translation, that's a slide. Translation, that's the first one we learned. What's the second one we learned? Who's got this one? What's the second one? Thalia, do you remember the second transformation we learned? So we just learned it at the end of last week, and we had a quiz over it. Can I give you a big hint? The slang for it's a flip. Flip sideways, flip up and down. No, that's translation, because translation's got the SL in it. So slide would be a translation. A flip would be something else. Reflection. A reflection, yes. Okay, and then we have one more. So FL, flip, reflection. Forgot a E in there, reflection. Okay, and the last one is the one we just learned. What is it, class? Rotation. Okay, and that's a turn. You turn it. Okay, does this figure have rotational symmetry? Yes, I agree with you. And then if it does, find the angle of rotation. How do we find the angle of rotation? How many positions would look like the original? 3. So we're going to take 360, a full rotation, divide by 3, and then what is the result going to be? 5 different positions. And then you said the example, the result's going to be how many degrees?
Yeah, it's 3.
Oh, my bad. Why did I put 5? Did I say 3?
You said 3, but you put 5.
All right, 3. And so how many, what's the degree of angle of rotation? 120 degrees. All right, so let's take a look at these down here. Now we're talking about counterclockwise rotations. So if I have triangle ORS or RSO, how many degrees counterclockwise, this direction, would I turn it to get to that new position? 270 degrees. Okay. How many degrees would I rotate this to go from here? 90 degrees. Very good. And then last but not least, how many degrees to go from here to here? 180.